So let's go ahead and do another example here, a very, very important example. So example 2, let's see here. Find the integral of the vector field f of xy is equal to minus y over x squared plus y squared, x over x squared plus y squared, around the circle of radius 4 from 4, 0 to the point 2, 2 radical 3. So in this particular case, they're actually giving us two specific points. We're going from this point to this point. So what we're going to have to do is, in order to find the parameterization, we're going to have to find the lower and upper limits of integration. We're going to have to convert this point and this point to t values based on the parameterization that we choose. Okay, so let's go ahead and do a little geometry here just to see what this looks like, so we make sure we understand what we're doing. So we have this circle of radius 4, right? This is 4, that's 4. We know how to parameterize that. That's going to be 4 cosine t, 4 sine t. And what we're doing is we're going from this point, the point 4, 0, all the way to this point right here, to 2 radical 3. And we're moving in this direction, that direction. That's the parameterization. So our c of t is going to be the 4 cosine t, 4 sine t. Now, when we do the integration, we need values of t because we're integrating along the curve. So it's t is going to be, the t values are going to be the lower and upper limits of integration. So this point is represented by t equals 0. So at the point 4, 0, t equals 0. So that's our lower limit of integration. Well, how about here? What's t going to be when we get to here? Well, at the point 2 rad 3, well, let's go ahead and solve. 4 cosine t is the x value here. This is the y value. Let's just go ahead and solve for t. So 4 cosine of t is equal to 2. Cosine of t equals 2 over 4 equals 1/2. And since we're in the first quadrant, t is equal to pi over 3. So we're going to be integrating from 0 to pi over 3. That's our lower limit of integration. That's our upper limit of integration. So notice in this case, they didn't give us the parameterization and the t values that we're going to traverse. They gave us 2 points, and they gave us just the geometric on this unit circle. We came up with a parameterization. That shouldn't be a problem. We need to find out what the t value is, so we have to evaluate one of these to find the t values. From t goes to 0, as t moves up to pi over 3, that covers that segment of the circle. Okay, so t is going to run from 0 all the way to pi over 3. All right, so let's go ahead and solve the integral. Well, f of c of t, when I put this parameterization into there, I end up with the following. I end up with minus 4 sine t over 16 cosine squared t plus 16 sine squared t, and I end up with 4 cosine t over 16 cosine squared t plus 16 sine squared t. Okay, this of course is equal to minus 4 sine of t over 16 cosine squared t sine squared t is equal to 1, so that factors out. And I have 4 cosine of t over 16. Let's get rid of these little random lines that tend to show up in the bottom of the page. Okay, so this is going to equal sine t minus sine t over 4, and I'm sorry, minus 4. Oh, this is ridiculous. Let's see. Minus 4 sine t divided by 4, and 4, no, I've already canceled. Now I'm the one that's messing up my arithmetic. Okay. 4 and 16, 4 and 16. So I get minus sine t over 4, and I get cosine t over 4. How's that? That's good. Okay. Now, excuse me, let's do dc dt. So dc dt, or c prime of t, that's going to equal minus 4 sine of t and 4 cosine of t. So f of c of t dot dc dt is going to equal, let me rewrite the f of c of t again. F of c of t is going to equal minus sine t over 4 and cosine t over 4. So it's the dot product of this thing and this thing. When I do that, I am going to get sine squared t plus cosine squared t, and that is going to equal 1. So our final integral, the integral of f over this particular curve, is going to be the integral from 0 to pi over 3 of just plain old dt, 1 dt. And of course, that equals pi over 3. Okay,